Hi children, today we are continuing with our second chapter acids, bases and salts, and in that chapter we are going to discuss the topic measuring the strength of acids and bases. Measuring the strength of acids and bases. In the beginning of the chapter we discussed about different types of indicators like litmus, phenolphthalein, methyl orange, etc. What is the function of those indicators? They help us to determine whether the given solution is acidic or basic, whether the solution given is acidic or basic. So, by color change they tell us whether the solution given to you is an acid or a base. But among acids and bases we have different types, like some acids are strong, some acids are weak, some bases are strong, some bases are weak. So, we have to distinguish between strong acids and weak acids, strong bases and weak bases. But using those indicators like litmus, phenolphthalein, methyl orange, etc., such a distinction is not possible. So, here we go for another method of measuring the strength of an acid or a base. Okay, that is done with the help of an indicator known as universal indicator. That is done with the help of another indicator known as universal indicator. It is a mixture of several indicators. Universal indicator is actually a mixture of several indicators. Okay, and universal indicator measures the concentration of hydrogen ions in a solution. The universal indicator measures the concentration of hydrogen ions in a solution, and at different concentrations of hydrogen ion in a solution, this universal indicator gives different colors. The universal indicator gives different colors at different concentrations of hydrogen ion. And the scale of measuring the concentration of hydrogen ions in a solution is known as pH scale. The scale of measuring the concentration of hydrogen ions in a solution is known as the pH scale, where P stands for small p, this small letter P. P stands for a German word potence, which means power, and H stands for hydrogen. So, measuring the strength of an acid or a base is done using a pH scale, where P stands for the power, potence which means power, and H stands for hydrogen. Actually, using this pH scale, we are measuring the concentration of hydrogen ions in a solution. Okay. Now, coming to the pH scale. In the pH scale, actually, we make use of a paper known as a pH paper, and also along with the pH paper, there will be a standard color chart. So, in the system of measuring the strength of acids and bases, we make use of a pH paper which is coated with the universal indicator. The paper that we use to measure the strength of an acid or a base is known as pH paper. It is coated with the universal indicator. And along with the pH paper, there will be a standard color chart. There will be a standard color chart in which you have colors varying from, red, different shades of red will be there, to deep green color, deep blue color. So, the color varies from red to deep red to deep blue. Corresponding to each color there will be values. Corresponding to 0, corresponding to deep red color, it is deep red color. Deep red color, the value will be 0, and the deep blue color, the value will be 14. Okay, so in the standard color chart, we have colors varying from deep red to deep blue, and corresponding to each color, there will be a value written from 0 to 14. So, in the standard color chart, we have values ranging from 0 to 14, and the colors range from deep red to deep blue. Now, let us see what we are doing to measure the strength of an acid or a base. Here, you will be given a solution. You are given a solution. Take the pH paper and dip it in the given solution. Take the pH paper and dip it in the given solution. Now, you will see a color developed in the pH paper. A color will be developed in the pH paper. Compare this color with the standard color chart. you have to compare this color with the standard color chart. So, if it is deep red in color, corresponding to that the value is 0. So, the pH of your solution is 0. pH of your solution is now 0. And the pH scale, as I told you, so this is the pH scale where you have values from 0 to 14. In the pH scale, you have values from 0 to 14. 0 stands for a strongly acidic solution. 14 stands for a strongly basic solution. Okay, so in the pH scale you have values from 0 to 14. 0 stands for a strongly acidic solution. As I told you, if you are getting a deep red color, value corresponding to that deep red color will be 0. So, it means that the solution given to you is a strong acid. Now, if it is deep blue in color, the value corresponding to that will be 14 and it indicates a strongly basic solution. And in exactly the midpoint, you have value 7, which stands for a neutral solution. In 7th standard, you have learned about neutral solutions, solutions which are neither acidic nor basic. They are like salt solution, distilled water, sugar solution. They are neutral solutions and their pH value will be exactly 7. The color corresponding to a neutral solution is green. A green color you will get for a neutral solution. For strong acids, it will be in the reddish range, and for strong bases, it will be in the bluish range. Okay. Now, the value from 0 to 7 corresponds to acidic solutions. If the value, the pH value that you are getting is in the range 0 to 7, your solution is acidic in nature, and from 7 to 14, after 7, it is a basic solution. Okay, 0 to 7, if the pH value that you are getting is in the range of 0 to 7, it is an acidic solution. If it is exactly 7, it is a neutral solution, and greater than 7 to 14, it is a basic solution. So, you will be in between, you will have values 1, 2, 3, 4, 5, 6, etc. Suppose the value that you are getting for your solution, the color that you are getting matches to number 6. So, what is the strength of your acid, whether it is a strong acid or a weak acid? Lower values of pH corresponds to strongly acidic solution. Please keep in mind, higher values of pH corresponds to strongly acidic solution. So, if the pH value is 6, value is higher, but your acid is a weak acid. Okay, and strongly acidic solutions have maximum H plus ion, hydrogen ion concentration. Okay, so in the last class we saw the acidity of all acids is due to the presence of hydrogen ions. Acidity of all acids is due to the presence of hydrogen ion. So, a strong acid will have maximum concentration of hydrogen ion. So, pH value 0 means a strong acid and it has maximum concentration of hydrogen ion. Okay, and as you move to the right hand side, you are moving towards the right hand side as the value become 5, 6, etc. Value is higher, pH value is higher, but the concentration of hydrogen ion will be less. Hydrogen ion concentration will be decreasing and the strength of the acid will be less. They are weak acids. pH value will be higher, but the concentration of hydrogen ion will be less. Okay. So, as you move from left to right, acids, what happens to the acid strength? Acid strength decreases. Okay. Now, in this range, so a strong, what is the reason for the basicity of all bases? The presence of OH minus ions, hydroxide ion, and a strong base will have maximum hydroxide ion concentration, OH minus ion concentration. Okay. And as you move from 7 to 14, basic strength increases. So, a higher value of pH indicate a stronger base. pH number 14 stands for a strong base. As the pH value increases, basic strength also increases. But in the acidic side, it is the opposite. As the pH value increases, acid strength decreases. Okay, I hope it is clear to you. the strength of an acid or a base is measured using a universal indicator. Okay, universal indicator is a mixture of several indicators, and the universal indicator measures the concentration of hydrogen ions in a solution. And at different concentrations of hydrogen ions, the universal indicator shows different colors. And the scale of measuring the concentration of hydrogen ions in a solution is known as the pH scale, where P stands for potence, that is power, meaning power, and H stands for hydrogen. So, in the pH scale we are measuring the power of hydrogen ion. Okay. And in the pH scale we can have values from 0 to 14. We have values from 0 to 14. 0 stands for a strongly acidic solution and 14 stands for a strongly basic solution. We make use of a pH paper. We dip the pH paper in the solution given to you. So, accordingly a color will be developed. You compare this color with the standard color chart. Okay. So, the color that developed will be matching with the color in the standard color chart, and corresponding to that color there will be a value. If it is 0, it stands for pH value 0. It means that your solution is a strongly acidic solution, and strongly acidic solutions have maximum hydrogen ion concentration. As the pH value increases to 7, the hydrogen ion concentration decreases, or strength of the acid decreases. So, for acids, as the pH value increases, acidic strength decreases. Okay. And for bases, bases have values from 7 to 14. pH values of bases stands in the range 7 to 14, and as the pH value increases, basic strength also increases. pH value 14, the color will be deep blue color and it will have the maximum hydroxide ion concentration. pH value increases, basic strength also increases, 7 to 14. But 0 to 7 it is the opposite. pH value increases, acidic strength decreases, and the hydrogen ion concentration also decreases. Okay. And 7 stands for a neutral solution which has exactly pH value 7. Distilled water, salt solution, sugar solution, etc. have pH value 7 and they are neutral solution. Now we will see what are strong acids. Examples for strong acids. What are strong acids? Okay, acids which undergo complete ionization. Complete ionization when dissolved in water. When dissolved in water are known as acids which undergo complete ionization when dissolved in water are known as strong acids. Complete ionization means, and the number of, they produce more number of H plus ion. These strong acids produce more number of hydrogen ions when they are dissolved in water. For example, hydrochloric acid, sulfuric acid, etc. These are the strongest acids. Now let us see what is complete ionization. In the last class I showed you how in presence of water hydrochloric acid undergo ionization. It splits into H plus and Cl minus. Sulfuric acid also undergoes ionization to give hydrogen ion and sulfate radical. So, ionization will be complete and all the hydrogen atoms present in the molecule will be changed into hydrogen ion. So, actually it is the power to produce hydrogen ion when mixed with water. So, they produce maximum number of H plus ions when they are dissolved in water. Please keep in mind, it is not the number of hydrogen atoms in the molecule that decides whether it is strong or weak. It is the number of H plus produced when it is mixed with water. So, HCl, hydrochloric acid and sulfuric acid are strong acids. They undergo complete ionization when they are dissolved in water, or the amount of H plus ions, hydrogen ion produced is more when dissolved in water. Now, let us see what are weak acids. It is the opposite. Weak acids, they undergo incomplete ionization, incomplete or partial ionization when they are dissolved in water. Incomplete or partial ionization when dissolved in water. In water, that is very important, writing in when dissolved in water. So, incomplete or partial ionization, and the number of H plus ions will be less. They produce less number of H plus ions when they are dissolved in water. The examples are, let's see the examples. One is H2CO3, carbonic acid, and one more. This is an entirely new acid for you. Name is familiar to you, but the formula you haven't seen. Acetic acid, CH3COOH. This is an organic acid. That's why the formula looks like this. We will learn about in the 4th chapter. Now just learn the formula. Carbonic acid H2CO3 and acetic acid CH3COOH. That's how we say CH3COOH, acetic acid. Okay. Now, as I told you, please keep in mind, it is not the number of hydrogen atoms that decide whether an acid is strong or weak. Here there are 4 hydrogen atoms present, but when it is mixed with water, the amount of H plus produced will be less. That's why it is a weak acid. Okay. The amount of H plus ions produced, that decide whether an acid is strong or weak, not the number of hydrogen atoms in the molecule. Here it has 4 atoms. HCl has only 1 hydrogen atom, but it produces more number of H plus ions when dissolved in water. Here when it is mixed with water, ionization will not be complete. Splitting into ions will be partial and more number of H plus ions are not produced. So it is a weak acid. Similarly, we have strong bases. Definition is almost the same. Strong bases, they undergo complete ionization in presence of water. When dissolved in water, they undergo complete ionization and they produce more number of OH minus ions. Examples are potassium hydroxide, sodium hydroxide, etc. Okay. So bases which undergo complete ionization when dissolved in water are known as strong bases. They produce more number of hydroxide ions, OH minus ions in presence of water. Examples are potassium hydroxide and sodium hydroxide. Now the last one, weak bases. Weak bases. Here also ionization is incomplete. Just like weak acids, here the ionization is incomplete or partial. Incomplete or partial ionization in presence of water. So the number of OH minus ion will be less in number. The number of OH minus ions produced will be less. The examples are calcium hydroxide, magnesium hydroxide. Okay. So weak bases, the bases which undergo incomplete or partial ionization in presence of water when dissolved in water, and they produce less number of hydroxide ions. Examples are calcium hydroxide and magnesium hydroxide. I hope it is clear to you. So what is the difference between strong acids and weak acids? What is the difference between strong bases and weak bases? These examples you have to keep in mind. Strong acids, we have 2, hydrochloric acid and sulfuric acid. They undergo complete ionization to produce more number of hydrogen ions. Weak acids are carbonic acid and acetic acid. Incomplete or partial ionization in presence of water to produce less number of hydrogen ions. Now strong bases, complete ionization to produce more number of hydroxide ion. There are only 2, KOH, potassium hydroxide and sodium hydroxide. Then weak bases, incomplete or partial ionization in presence of water, and the number of OH minus ions produced is less. Calcium hydroxide and magnesium hydroxide are examples. Okay. So that's all for today's class.